In this video, we'll see how we can design an automatic systems instruction optimization where we have a application which is an AI driven application, and the systems instructions in that application is not performing well, giving us not good results. And how can we design a system where we can optimize this instructions automatically? So that's the question that we need to come up. We have to come up with our own design and how we would do this. It's a it's a fun applied AI system design question that we need to tackle. So the first thing is we need to understand what does we should be ready with these three things. One is the goals, then scope, and the third one would be rules or guardrails. So while designing some anything related to applied AI, I think these three things cover most of the aspects that we will be doing. If you are in an interview, I think this would help a lot. So in this case, we have some systems instructions which are not doing giving us good results, and then we need to optimize it, and it should be automatic so that whatever happens, we get the best out of those systems instructions, right? So how first the question that we need to ask is, how do we know that they're not performing well? So ideally there would be a evaluation system into your applied into your AI application, right? So the evaluation system would be evaluating and would have metrics where we are getting response indicating the responses are not good, or it could be many other things. And the core problem is the systems instructions are not that good, right? So for this particular problem, let's look at the goal that we need to achieve. So you can list them down as you think about it. So I think first would be, since we know we are getting these we are not getting good responses from the evaluation system. So most of the metrics. So what we need to do is we need to improve the quality metrics, and it could be anything. Let's say you ask a question to your multi-agent system, and the response is not formatted, right? So the quality of the answer is not good in based on formatting. So that could be one of the metric that is not working correctly, or the accuracy is not good, right? So this would be another metric that we need to uh, answer. Or the JSON is the response is not JSON. If you want a JSON response, it is not in the correct format while returning. So these are a few things that would not be working because we have not clearly instructed into this current systems instructions. That's why it's not working, right? So first, I think our task would be making sure that we improve the quality, right? The second would be we need to make sure that at any given point of time we make changes to our prompt or the instructions. What if the previous answers do not work? So we need to maintain zero regression on the golden data set. By when we say golden data set, is the data set where everything is checked based on that. So basically it means that meaning we do not break things that were working before, right? So this we have to maintain zero regression on the golden data set. The golden data set means that when you created an evaluation system, you might have used this data set as your reference, making sure that your answers are correct or not, right? So we have to maintain that. We have to make sure that once we change the instructions, the previous things still keep on working. So we have to make sure that happens, right? Now let's say if you change the instructions, there might be possibility that the answer and the inference latency has changed. We should not we should not increase it. Even if it does, it shouldn't be that much, right? So we have to maintain this as well. And when we say that we need to optimize the system's instruction, it doesn't mean that we uh, replace it with an entire new text or from a 200 word instructions to, let's say, 2000 long text, right? So fixing into 2000 long test not to do this, right? So we don't have to do this, right? We have to make sure if we don't do this and then solve the problem. That's not how we would design a system, and makes perfect sense, right? So if you're giving an interview and need to explain this, I think you can elaborate it, but don't spend a lot of time onto that. Okay. And one more thing that we can understand is the token cost. So when we are trying to optimize everything, we are increasing. So keeping a track of token cost should be there as well. So you could have a parameter and a metric around this, right? So it should not increase by X%, and then you can say like let's say 10% for this scenario. It should not increase by 10%. So these are different goals that we need to set for our design, right? So let's do this applied AI, right? So the next thing would be scope. What are we actually going to do in our design? You can tell this in a high level. So we could say, uh, since in the start I mentioned that it's an evaluation system that is telling us what is going wrong. So what we need to do is we need to find all find the failing data sets, failing queries, values, data sets that is there from the eval system. Okay. And so basically we check what is failing, right? And the failing could be in any other form, in any form. We can discuss this when we start building the system, right? So just figure out what is going wrong, right, from the evaluations, and get it. Now there could be a possibility like formatting, accuracy, JSON are three different types of quality metrics that are getting affected because the instructions are not good, or they have changed with time. The users are not asking the same questions again, right? It could happen by because of multiple reasons. So let's do one thing. We could cluster it based on semantics, right? So everything that is related to formatting goes into one cluster, and then accuracy into another, JSON into something else. That gives us an understanding that how many examples were actually failing of one category, right? That would be one. And then once everything goes, we can have a human in the loop for approval. We don't want our system to make the final guess and start deploying or changing the configuration to the new instructions. It's better to keep someone in the loop, and it is always better um, who does the approval and then it goes ahead, right? So we'll keep it very short, right? This is not the actual solution, but the way you can say this is what we would be doing. So you can actually add this saying that modifying the existing prompt, the system instruction slash prompt, right, in the application. And then you can add one more point saying that um, you could say ranking it or checking the score, evaluating the score of the of the modified system instruction, right? And so you can write multiple steps based on how your interview is or how you're trying to understand your design, right? So that would be the scope. The next thing would be rules and then guardrails that we need to make sure, right? uh, One of the things that you should take care of would be if you have modified your system's instruction and the score of the new modified and optimized system instruction is not good and the current one is already good, so you should not even evaluate further, right? So the new and optimized uh, system instruction should always be better than the current one. We have to make sure this is what we are working towards, right? And keeping a rule for that. Then maybe we could also have something called as a safety rule, where the final decision is with the human, right? So that makes sure that we are not going in the right direction that someone has already taken a look at. And then the last could be something as a budget rule, where we should not spend more than X cost in optimizing the system's instruction. We don't want to spend a lot of money into this, right? Uh, it should be something that you decide based on your use case. So you can add a lot of more stuff to this, but this is just how you could get started, right? You have goals, you have scope, then you have rules and guardrails, and now you develop your design based on these approach that you have come up with, and you can keep on discussing with your interviewer if you talk to them, and if there's something else they would always tell you, hey, let's change this to another thing, and this is not valid in our use case, let's not talk about it, something like this, and you can modify your approach accordingly. Awesome. So once you're done with this, now let's try to actually design the system. So the first thing that we discussed was the evaluation system, right? So if I have an eval system over here, which is tracking all metrics of your application, right? So we are getting all the information from here, and we think now things are not working as per expectation, right? So we have this over here. The so we get all the data from this particular place. So what we do is we take data from this, and we need to create something called as a failure data set creation, so, which means that things that have been failing into our system have to be brought over here, and then it could be so the decision that you can make is that all the things that had a score less than zero point 0.5, everything that is less than zero point 0.5 is not a good response in any of the domains, right? So just take that, whatever that is one of the ways you can create a failure data set, right? And then we have grouping them, we cluster them rather based on semantics, right? So all the scores and the inputs, everything would be inside this. So it, we would have the inputs, we would have the actual output which was given, and then expected also, right? And we should understand that the expected output is ideally, like I said, everything was tested based on a golden data set. So what we can do is we can have a golden data set, right? So everything was getting uh, checked based on this particular golden data set and the evaluation system, and we have our application somewhere here, right? Now we are designing a system based out of that. So if you have that in place, now we have this. So based on these information, we have scores, we have clusters, we can also add the name of the agents, maybe the text that was wrong, some keywords. All of this can be part of this particular uh, block. And what we do is, out of all this information, we create our failure data set. Okay, and it could be here somewhere. So this becomes a failure data set, and once we have that, now we have the golden data set and we have the failure data set. These are all the wrong things that have happened because our instructions were not good, instruction changed, or something would have happened. The user's behavior has changed towards your application, which is very much likely to happen. Now, once we have that, what would be the next step? Our approach in getting the best getting the unmodified, optimized instructions would be after this. So we have got the things that are not working. We need to improve this. We need to make sure these pass, even if the system instructions are the same as is once after modifying, right? So there are multiple techniques that you can do this with. So what we are going to do is we are going to go and create another block that would act as an optimizer. So the work of this app optimizer is the actually modifying the system's instructions. Okay, so and there are multiple techniques that you can do it. One that comes to the top of my head is called an optimization uh, prompting. It is also called as OPRO for LLM models. There's a paper on this which you can go ahead and check. So there's this particular technique. There are multiple techniques, so you can use this. What it actually does is, given the data of input, actual output, and expected output, it will try to optimize it in the best possible way using a large language model. Right now, this is the optimizer that we have. Okay, so what this will actually do is create. So the main task of this optimizer is actually creating three different valid, modified, and optimized systems instruction. Why three? We'll talk about that too. So ideally, what we'll do is we'll have uh, a prompt over here that is more like, let's say, generate. So the LLM is like, you are a expert in prompt engineering, right? Generate three candidates that based on the above data, right? Here is the current systems instructions, then examples, or you could just say failure data, uh, and whatever you have, right, and more you have. So this is the instruction that you give, which comes actually from here, right? So optimizer is over here. It will create three different versions of. So this particular optimizer is going to output three different versions, right? V1, let's say V1, V2, and V3. So it created three different candidates based on the issues that we found, right? And these are the issues we passed to the optimizer. It used some techniques that we have available. You can use any of them. This would be the prompt of the optimizer, and it has created three different versions. Now, these candidate prompts that we have are the optimized systems. Let's say prompts for now. So these candidate prompts would be tested. Now we do not know which one would perform the best, right? So what would be the next step? We have this in place. We got the failed data set that is not working. We have pulled them from the evaluation system. We put it to the optimizer. Write a very good prompt to generate three different versions of the system instruction, and the next step is actually the testing of this. So you can come here and you say test test the data with all versions, right? So main is we are going to pass all of these instructions one by one to this particular testing block, and what we are going to pass this is this these are the system instructions, and we are going to also tell them, hey, this was the failure data set, look at it and answer questions, and let me also give you the golden data set. So I've passed all the system instructions to the failure data set and the golden data set for it to make sure these three are giving better responses as compared to the current system instruction that we have in the actual application, right? So this would be the testing of whatever we have done. Once that is done, let's say this is done, right? Now we have to make sure that we design a system which actually outputs the score as well. So what we do is, once we test everything with each of the system, we create another block saying that, hey, once you get to can you rank them? So rank based on the ones which maximizes accuracy. So which of the following would maximize the accuracy of the responses on failure as well on failure data set, and maintain the golden data set also. So this particular block means that, hey, I tested it across multiple, I tested the v1 across the failure data set. Now I see that out of, like, let's say the examples were like 20, right? So for example, let's say 20, let's say 40, and 40 inputs were given with all the information, right? Out of this 40, now I can confidently say that with our current it was 40, but with v1 I can answer now 38 of them, while I maintain the golden data set almost zero. Or you can make that improvement also, but ideally we should try to keep it zero. We don't want the previous answers to fail just because we are trying to fix this, which is very important, right? So that would be one. So ideally it would be, we get this, we get v1, then it would do the same thing for v2. So we would rank them based on some scores, and in the end maybe v2, v1, and v3 work as the ranking of it, with the assumption that all of them performed better than the existing instructions that were there, right? So this is very important. We don't want v2 is better than all of three but worse than the current one, right? So we don't want that. So this is what we do, but we need to make sure that happens every time, right? And it might not happen. We might not get all of them like this. So if v2, v1, v3 is a ranking, and v2 is not good than the existing one, then all the other two are also not good, right? That's how we have ranked it. So ideally what we should do is maybe have a condition that would actually go back. So we have new scores. New scores are better is what we need to check, right? When I say scores, new scores, let's do new scores of each version, right? So of each version, are these better than what we had, right? So if you have something like this, what we do is we are at this location, and then we come over here, and we say let's make we come here, one arrow over here, and what we say, let's say this is good, it is better, right? So it is better. So I think then if that happens, the only thing that we need to do, have a human approve this these versions and accept the one that you like, right? So once we do this, I think it gives us confidence that, hey, a human has also reviewed it. But what if it doesn't work? So if it doesn't work, the idea is that we should go back to our optimizer, right? So the optimizer did not do a good job. For it could be for any reason, right? So ideally we should go back, and once we go back, this would be when the response is not good, right? So you go back, and that's the loop. And there are multiple things that you can do in this. You shouldn't loop it multiple times, right? Maybe add a number of, for add limit to the loop, to the number of, let's say, number of iterations, right? And then you can do the best out of it. So this becomes your entire design. It might not be the best one, but in like in 30 minutes you can come up with something like this. If you're an interviewer, one of the initial designs of your auto auto systems instruction and optimization of the systems instruction, right? So this is one way that you could do it, and we should make sure that these things are getting covered, right? So are you modifying the existing system? Yes, we are, right? Are we ranking them? Yes, we are. Is there a human in the loop? Yes. Are you finding all the failing queries, values, data set metrics, everything? Yes. And then we are clustering it as well, right? And then uh, to do a little bit more on the deep dive, we should have let's say at this particular location, right? Uh, let me Here is where we could write a token calculator, token cost calculator, something like this, which is keeping a track of all the things, and we could add that. So that could be one. And you can, so here is where what we do on our own, but here is where we have an LLM, right? So we could have a token cost calculator over here that would help us, right? And when we do this v1, v2, v3 in this particular system's instruction, we make sure that we have the limitations, like the modified version should not be more than x words or three paragraphs and stuff like that. So these conditions we need to add while we develop the system, and it could be in more in the deep dives, right? So, but this would be the high level way that you could design a system if asked to you in an applied AI domain, if you work in that domain, right? So this gives you a picture where you have covered most of the things. And once this happens, you so your evaluation system is always tracking if it is going 0 less than 0.5, and the entire system design is activated. And you have fail checks. You're making sure nothing goes into an infinite loop because you have a limiter over here and stuff like that. This helps. This would be the approach, creating a design like this. So if you have any questions related to this, any different ideas, I think I would be happy to know about it. If something is wrong, I would happy to be please be open to comment that so I could add it and we can improve this. Awesome. Thank you. Thank you so much.